Welcome back to the final session of the I²CNER Annual Symposium 2012, which will present the last two of the I²CNER's research thematic areas, CO2 separation and concentration, and CO2 sequestration and storage. And our last session chair today, Satellite Institution Principal Investigator, Professor Dimitrios Kiritis of the University of Illinois.
Thank you very much. Thank you. Welcome once more to our fourth session for the day. Our first speaker is going to be Professor Katsuki Kusakabe, who is a WPI Principal Investigator in I²CNER in Kyushu University, and also a professor at the Department of Nanoscience in Soju University. Professor Kusakabe has had his education in Kyushu, culminating to a PhD in applied chemistry in 1982. He is the author of more than 300 archival publications, and this afternoon he will be talking to us about innovation for CO2 separation technology. Professor Kusakabe.
Thank you, Professor Kiritis, and for kind introduction. First of all, I would like to introduce our target of our groups is construction of economically feasible carbon dioxide separation system. This is our target. And our group, we have 4 persons, and Professor Minemoto and Professor Matsukuma, one group. They work at the absorption process, especially the electrochemical absorption process. And Professor Fujikawa, he prepared the ultra-thin membrane, that's nano, it's called as nano or membrane. And he just joined to our group last year. And finally, me and with its absorption groups, and we developed the novel microporous materials for CO2 separation. Of course, we are going to collaborate with other I²CNER group in Kyushu University, and also we would like to collaborate with international research group, and especially the University of Illinois. And this is member of our groups, and Professor Paul Kennis and Professor Kiritis. Both of professors joined in this annual symposium, and I hope that fruitful discussion between our Kyushu University group and the Illinois groups for the exchange information and detailed future research work. So next, we would like to introduce our activity toward the I²CNER's goals, and as mentioned before, present from the March 11 to 2011, the power plant, atomic power plant crisis occurred, and then the energy resources is shifted to the use of fossil fuels. Therefore, the carbon dioxide separation, research of carbon separation work has become an urgent research subject. Then also, the carbon dioxide separation is a key issue of CCS technology. And also, we have this technology we have, but this technology is a common technology to the production and the storage of hydrogen, and also the fuel cell systems. Therefore, that we also collaborate with the other groups in Kyushu University. So let's introduce the next is our group's activity. So this is absorption, one of the absorption process and electrochemical absorption method. Usually, absorption process is a simple process, just absorb the materials, absorb the carbon dioxide, then dissolve the carbon dioxide. That's all. Therefore, the process is very simple. Therefore, the many researchers engaged in the development of advanced adsorbent. But in this process, we use the electrochemical method, and the separation and absorption is a simple one. That's to absorb the carbon dioxide from the effluent gases. And then next step is important, that absorbed carbon dioxide is usually very diluted one. Therefore, that we have to concentrate it by using the electrochemical force, and also by using this kind of ion exchange membrane through the some CO3 minus ion and HCO3 minus ion, they pass through the membrane. Then carbon dioxide source is concentrated. And after that, concentrated carbon dioxide is dissolved to the and then we can recover the carbon dioxide. And this is simple. This is not process innovation of carbon dioxide separation to absorption. And leading PI, Professor Minemoto, carried out the adsorption process many years. Then he calculated the estimation of energy consumption of carbon dioxide. This is one of the example of calculation. If we use the conventional adsorbent, such as a zeolite and so on, then in this case, this desorption gas temperature that is energy consumption indicated the minimum value at 150 degrees C. That's relatively high, because therefore we put the energy from the outside. Then the value of minimum energy consumption is about 3,000 kilojoules per kilogram. That means that carbon dioxide, 1 kilogram of carbon dioxide emitted, and then 3,000 kilojoules of energy is required. So that it's compared to the total generated energy, that which is close to the 20% of total generated energy of this kind of power plants. Therefore, the development of adsorbent with excellent desorption property at temperature is very important. So, next, this is work by Professor Fujikawa. He already established the preparation method of ultra-thin membrane. That and I will show you that then he prepared the ultra-thin nano membrane, or ultra-thin membrane, that it's applied to the electronic device and the optical device, and other case is liquid filtration for molecular sieving. But right now he prepared a ultra-thin membrane for CO2 gas separations. This is the evolution of electrochemical absorption process. Professor Minamoto carried out the experimental work, and he also calculated the total energy consumption of this electrochemical CO2 absorption method. Then the calculated value is 785 kilojoules per kilogram CO2, and the ideal condition. That then Professor Minemoto improved this process. Initially, he used the electrochemical cell with a high current operation mode, and then shift to the second stage. He used the electrochemical cell with high voltage operation. And so this year he will change the streamline a little bit. Then we improve the energy consumption. And this is, once again, I would like to introduce, this is a numerical target in our groups. Professor Minemoto stressed this target. And our target is energy consumption for carbon dioxide separation should be less than 1,000 kilojoule per kilogram CO2. But usually many researchers modify the adsorbent and adsorbed material, adsorbent and membrane materials. Then that's conventional modification of conventional adsorbent. In this case, the target of conventional target of energy consumption is 2,000 kilojoule per kilogram. Then that we need inhibition technologies. So this is one kind of our research group. Then we prepared a metal organic framework crystal formed on the porous aluminum membrane, and it's applied to the membrane separation. I was sick. And there are many items for future work for individual researchers from here. But we just started the collaboration work, then collaborated with Professor Kiritoris. This is University of Illinois for chemical approach on carbon dioxide flow at high pressure. And collaborated with Professor Kennis, also University of Illinois, and for microchemical system for CO2 separation and for CO2 utilization. And okay, I skip. This is a summary of our research groups, and I research work in the CO2 separation and concentration group could take off last year, and we repeatedly discuss the mutual research items, and then researches for process and material development have been conducted with focus on carbon dioxide desorption, which is energy consuming. We focus on the CO2 desorption. And this year, we promote our activity. To promote our activity, we have collaborated with CCS group and the hydrogen group and the fuel cell groups in I²CNER and researchers in University of Illinois. Thank you very much for your attention.